Electrical vehicles offer a promising route for providing transportation without the carbon dioxide emissions of traditional vehicles. In particular, when charged by renewable energy sources such as wind, water or solar. In fact, electromobility and renewable energy form a perfect synergy. Electric cars are powered with lithium-ion batteries. If the batteries are preferably recharged during periods when green energy, for example wind energy, is abundant, then the electric car runs virtually pollution-free. What's more, the car could not only consume green energy, but could potentially also feed it back to the grid if needed.
There are many critical issues, I would say. There's of course on the car side, we have the issue of the batteries themselves. Will the batteries be cheap enough? Will the batteries be powerful enough? Will the batteries be reliable enough? So this is an aspect of the hardware. Then when you start thinking about smart charging, where we essentially compute for every car when should the car charge or discharge power into the grid, we have to communicate this to the cars. So there is an issue in communication with the car from the central planning place, and this communication has to be reliable, it has to be reasonably safe and secure, etc., etc. So this is another big challenge. And then of course the optimization work that we are doing here in Zurich, where we are experimenting with optimization algorithms to derive in some sense the optimal charging behavior, optimal in the sense that the end customer will have enough power in his car to actually drive, yet on the other side that this power is mainly provided from renewable sources, i.e. In that case wind.
To solve these integration problems, the IBM researchers are developing a simulation model to optimize the charging so that a maximum amount of clean energy is used. The Danish island Bornholm serves as the basis for the simulation. The small and picturesque island is also the testbed for the 3-year collaborative EDISON project. The project aims at designing and implementing smart grid concepts that make possible a large adoption of electric cars powered by wind energy. The optimization model of IBM researchers is used by the EDISON consortium. IBM scientist Ulla Sundström, who designed and developed the application together with Carl Binding, explains.
We developed a simulation environment that allows us to study the electricity grid and then a large fleet of electric vehicles traveling over this grid, and then play around a little bit with different types of smart charging methods and optimization techniques for this.
With these smart charging models that deliver optimal use of the grid and resources, IBM Research helps to create an interconnected and sustainable energy system, thereby paving the way for climate-friendly e-mobility for a smarter planet.